For this learning objective, there are so many molecules that we could use to just practice identifying functional groups in molecules. I'm going to do it with an arbitrary order for about 16 different functional groups. I'm just going to do really quickly. If you see something like this, you have to choose from one of 12 functional groups and just write the name. This could call a cycloalkane, or possibly could just be labeled as an alkane. How about this? You may have recognized that's an alkane again. Or what if we had something like you might recognize again that this is all C's and H's and all single bonds, so it's an alkane. Let's do another one. All three of these have sulfur, but they are chemically different. They react with molecules in quite different ways, and so they each have a different name as a functional group. This one looks like an alcohol, so it's called a thiol. This one down here is a sulfide, and this is more common in biochemistry and proteins, a disulfide. Okay, how about this? Or maybe something like this. You might recognize that both of these are alkenes. You can see what's changed there. Every hydrogen has been replaced with a fluorine. This is a fluorocarbon or a halogenated alkane. In this case, it's fully halogenated. You could have molecules with just one or two halogens attached. What if instead of an S, we had an O? Or maybe something like this. These are both alcohols. It gets more confusing if instead of a single OH, we had two OHs. I'm not going to learn that functional group. It's called a hydrate, but it's related to some others that we are going to learn. And this time the O is connected to a carbon. This is a hemiacetal. Going to learn about those because you find those in sugars. But one that you're learning now is still different yet. This is a carboxylic acid. And as an acid, it can lose its H+. If you take off an H+, you leave behind an electron, an O-, and this is a carboxylate. At any time you can be pausing this. This is just an exercise in drawing and recognizing simple molecules with single functional groups. How O's are attached really matters. Here we've got an O in between two carbons, but there's a hydroxyl group there that makes it a hemiacetal. What if we have an O in between two carbons with no other O's attached? This becomes an ether. Or we could put an O in between two carbons with a double bond O. There's an ester. So whenever you have an O or an N, you can't just look at what's directly attached to that O. You have to go another step away and see if there are more things attached to the carbon. Same thing happens if we go with N's. In this case, the N is attached to 3 carbons. In this case, it's attached to 1 carbon and 2 hydrogen. But the key thing is, off this carbon, there's a carbonyl oxygen, a double bonded oxygen. These are both amides. You'll learn classification that's also significant to their reactivity. This would be a tertiary amide, and this would be a primary amide, because here it's connected to 1 carbon, and here it's connected to 3 carbons, but that's something you'll learn more about elsewhere. If there's no double bonded oxygen there, then we call it an amine if the nitrogen is connected to carbons with no other heteroatoms coming off nearby on one of the connected carbons. One more group for this problem set that I haven't covered, and that is aldehydes and ketones. I'm going to draw a couple different molecules. Your homework, figure out which of those is an aldehyde and which is a ketone.